All right, so I finished my general announcements. Students were reminded that we have a CFU coming up this Friday, and homeworks 1 and 2 this week will be collected next week on Tuesday. Students got their first 2 packets of the year. They have a note packet, which we will use every single day in class. There's a homework packet, which students are allowed to take home if that makes things easier for them. And you can take your whole binder home if you prefer, but you do need that note packet in class every day. So you are allowed to just leave it on the bookshelf in the room if that makes life easier. Okay. Students were already given 2 minutes to complete the multiplication at the top of page 2, so I am ready to get going. The theme of today is use the calculator to help draw a graph. The first one is already done for us, so I'm just going to go through some of the steps for how to get the points themselves. Okay, so this says the function f of x equals x squared minus 1 is shown below. Complete the table, then plot all 7 points on the curve. So let me remind you of the way a function works. And this is something you should have learned in Algebra 1. F of x basically says, think of a number. Give me a number. Pick any number. 4? Perfect. So if you think of the number 4, what you're going to do with the number 4 is you're going to plug it in for this. Now, does anyone know what is 4 squared? Perfect. 4 times 4 is 16. And then we subtract 1, we get 15. So if this table had the number 4, you would say, all right, well, 4 squared minus 1 equals 15. Now, real quick, if I ever write in green, because I see a lot of you already taking notes, which is fantastic, I love it, but if I write in green, you don't need to copy it. When I write in green, it's my way of saying to you, don't worry about copying this stuff, it's just extra, we're having a conversation, okay? However, if I write in blue, like let's say that the number she had picked was -2. Anyone know what -2 squared is? Remember, when you square a number, it's that number times itself. So, oh, I love, was that you? I love that he said -2. I need my seating chart because I don't know names yet. There we go. Thank you, Jordan. So I love that he said -4 because I agree with half of that answer. 2 times 2 is 4. But what's -2 times -2? What's a negative times a negative? Positive, exactly. So -2 times -2 is actually positive 4. So this is what you're doing. You're doing, notice that's blue. So this I do want you to write down. It's blue, that means copy it. -2 squared is 4. And what is 4 minus 1, folks? 3. Now, I'm going to save your hands a little bit. We're only going to show the work for a couple of these. The other 3, we're going to cheat. We're going to use the calculator. Okay? If I do -1 squared, okay, so I take -1 and I plug it into the equation. Now, remember, -1 squared means -1 times -1. That's what squared means. Multiply the number by itself. So what is -1 times -1? 1. Remember, we're multiplying, not adding. Okay, so -1 times -1 is positive 1, because 1 times 1 is 1, and negative times negative is positive. So then you have 1 minus 1, which is 0. We're going to do one more by hand, and then I'm going to save your notes a little bit. I'm going to make you write less. Let's try plugging in 0. This is kind of a weird one. What's 0 squared? 0, because 0 times 0 is 0. Okay? I heard both Lucas and Isabella respond. I appreciate that. If you also responded, my apologies for missing you. Okay? 0 squared is 0, because 0 times 0 is 0. Minus 1 is -1. Now I'm going to switch to green. So you do not need to copy any of that. I don't want to kill your hand on the first problem today. It's also really repetitive, right? I mean, this is what a function is. It's take a number and square it, and then whatever you get, subtract 1. That's what this equation is telling you to do. Okay? Now, there's a really simple way that you can have the calculator do this for you. Check this out. Follow along with me. If you go to the y equals key, this is in the top left corner. We're going to be using this all year, folks. So I'm telling you now, practice it now so that this is easy for you in the future. Press y equals. This is the screen you go to type in equations. Now, what I want to type, I'm going to do this once really fast, and then I'm going to do it again where I explain what I typed. What we want to type is x squared minus 1. This is what we want on the screen, okay, because that's the equation, x squared minus 1. Let me clear that out and do it slowly. Notice this little button next to the alpha key. It says xt, and then it has this weird symbol. It actually stands for theta. and then it's N, press that button. That gives you X. Now I want to raise it to the second power. I want to square it. Well, there's actually a button that does that for you. It's this button right here. It's saying take whatever I have typed and square it. Now that's not the whole equation. We also want to subtract. So I'm going to subtract, that's over here, 1. Now if you hit graph, which is the top right button, you don't have to do this part. This part, if you just want to watch, just watch. You can just stay on the screen. But if you wanted to, you could look at this graph by just hitting the graph button. And it'll show you the picture. That's literally what's already on your packet. Okay, but what we're trying to do is we're not trying to look at the graph. We're trying to fill in the table. Okay, well, guess what? See how the word table is right next to the graph button? What color is the word table? Blue. So if you want to get to that, you need to hit the blue button. So now I do want you to follow along with me. Hit the blue button, the second key, because it's like the second command. I don't want the first command. That button, the first command is graph. I want the second command that's attached to that button, and that's table. That's the blue one. So now after you hit second, you hit graph, and that jumps you to the table. Now check this out. Right now it's at 0. It automatically is on 0. But let's pretend for just a moment we hadn't done any of this yet. Okay, let's just pretend we hadn't done any of that work yet. Okay, well, I need to see -3 and -2 and -1 and 0. So it's really simple. Notice how the numbers going down are positive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, that means the numbers going up are negative. So just hit up, 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 and you'll see the negatives. And now I can literally copy the numbers. -3 is 8. Well, they gave us that. -3 is 8. We found the next couple. We found that -2 is 3. We did that with our work right here. -2 got us 3. We did the work that -1 gets us 0. That's in the table. -1 gets us 0. We did the work that 0 gets you -1. That's also in the table. 0 gets you -1. It's the next 3, 1, 2, and 3 that I don't want to have to do the work. I just want to copy it off the table. Okay? So at 1, it's 0. At 2, it's 3. And at 3, it's 8. So 0, 3, and 8. Those are the other 3 numbers I want you to write. If you can do that, you can graph anything in this class that I ask you to graph. That's what I'm trying to teach you today. Just a little bit about how to use the graphing calculators. Now, before we get to the other practice problems, I want to remind you, because I want to make sure we know how to plot points. Remember that if you're trying to plot the point, say, -3, 8, the first number, anytime you're plotting a point, and my apologies if there's anyone in the room that I don't need to explain this, but trust me, there are some folks in the room that need to hear this. When you're plotting a point on the graph, you always start right in the center. The first number tells you how much to go left and right. The first number is always how far left, how far right do I need to go. Now, because it's negative, I'm going to the left. The second number tells you how much you go up and down. Because it's positive, I'm going to go up. So the first point, which is -3, 8, that's how you'd write that as a coordinate pair, okay, is telling you go left 3, so 1, 2, 3, then go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And it's right there. So it's talking about that point. So if I asked you to create this picture yourself, you need to know how to do that. Okay, the next point right here is -2, 3. Okay, let's just be clear on where I'm getting this. -2, 3. Well, that point is saying start in the middle, start at the origin, and go left 2, up 3. Everybody follow me so far? Okay. Next point is -1, 0. So that's saying start at the origin, go left 1, and then don't go up and down at all. Just stop. So I'm going to go left 1 and stop. Don't confuse this with, and this is what a lot of kids mess up, do not confuse -1, 0 with 0, -1. Those are two very different points. Because 0, -1 says start at the origin, don't go left and right at all. 0, don't go left and right at all. But then -1, go down 1. So that lands you right here. Notice I'm putting all these dots in green because the picture was already drawn for you. You do not need to copy these dots. I'm just explaining how if the graph wasn't already there for you, we would have needed to do this. Okay? Next point is at 1, 0. So that means go over 1, don't go up or down at all. Next point is at 2, 3. So that means go over 2 and up 3. And the last point is at 3, 8. So that means go over 3, up 8. And notice, if the graph wasn't already there, we would have enough points now where we could draw the curve ourselves. Okay? So what we're going to do with the rest of the period, I want to make sure my timing's good. Oh yeah, we're great. We're great. We have 4 problems to do. That's it. 4 problems. For each of these problems, I want to walk you through typing the equation into the calculator, then going to the table to copy some points, and then using those points to create the graph. That's the goal. And we're going to do it 4 times. Okay? Questions? All right, folks, go ahead and turn the page. So this is problem 1 of 4. We have 4 problems left to get through today. All right? So number 2 says use the function f of x equals 3x minus 1 to complete the table below. Be sure to show your work, then sketch a graph of the function by first plotting all points from the table. I'm going to tell you right now, because I really want today's focus to be the calculator, I am not going to require that you show any work right now. Go ahead and cross that out, because I really just want us getting comfortable with the calculator. So the function says, if you think of a number, plug it in right there for x. So in the first example, if you think of -2, plug in -2 for x. And what I'm going to say, notice all of this is green. I'm not going to make you do that for each and every one of these calculations. I'm not going to make you do that. Notice it's all green, so you don't need to copy any of it. But if we weren't going to use a graphing calculator, this is what we would need to do. We'd have to imagine plugging every one of those numbers in. -2, -1, 0, 1, 2, 3, 4. We'd have to imagine plugging those numbers in. Okay, so instead we're going to use the calculator, and we're going to plug the equation 3x minus 1 in. We're going to go to the table. We're going to copy the points. Okay, follow along with me, please. First off, I want to refresh the calculator. I'm going to reset it. I honestly do that every time I start a new problem. Okay, so I just remember that phone number, second plus 712. It's just a way of resetting the calculator, getting it fresh and ready for a new problem. I do it every time. So you're going to get sick and tired of me hearing, you're going to get sick and tired of hearing me say second plus 712, because I'm going to say it about 1,000 times this year. Okay? When I get convinced everyone knows that series of buttons, then I'll stop saying it. But until I'm convinced every person in this room has that memorized, I'm going to keep saying it. All right, so go to y equals. That's the top left button. That's the button you go to when you want to type in a function. Now, what I want to type in is 3x minus 1. So I hit 3. Then remember, the X key is next to the alpha button. So I hit that button with all those, the X and T and all that craziness. That gets me my X. And then I subtract 1. Now, I'm going to go to the table, because my goal is to complete this table starting at -2 and going -2, -1, 0, 1, 2, 3, 4. So my calculator, remember, table is the second feature of the graph key. So I'm going to hit second graph. Interrupt me or slow me down if you need me to repeat any of these steps. Now I want to go up so I can see -2. Yes, ma'am. For the equation? For the equation, I plugged in 3x minus 1. Okay, and I was copying it from the top of that problem. All right, so in the table, I want to start at -2, and I want to go all the way down to +4. So these are the values I'm going to copy. -7, -4, -1, 2, 5, 8, 11. So please take a moment. The -7 was already there for us, so I don't need to copy that. But I copied the -4, -1, 2, 5, 8, 11. Please copy what's in blue. If you want to copy what's in green, more power to you, but you need to copy what's in blue. And now I'm going to use these points to create a graph. Okay? So let me get rid of these. So the first point is -2, and when we plug in -2, we end up with -7. So that's the first point I want to graph, -2, -7. So I start at the origin. Remember, it's always left and right first. X is left and right. The value of the function is up and down. So I'm going to start at the origin. You always start at the origin, okay? And I'm going to go left 2 and down 7. Please plot a point right there on your graph. Notice the point is blue. So this is me saying this is something you should be writing. The next point is at -1, -4. So -1, -4. Notice, to get to that point, I started at the origin. I went backwards 1, so left 1, and I went down 4. That's how I got to that point. Every point you start at the origin. You go back to 0, 0 in the center. Okay? Jordan, you good? All right, looking at my next point, I've got 0, -1. So that means don't go left to right at all, but go down 1. Next point is 1, 2. So starting at the origin, go right 1, up 2. Then I've got 2, 5. So starting at the origin, go over 2, up 5. And then I've got 3, 8, and 4, 11. Now, here's where it gets a little weird. 3, 8 is fine, but 4, 11 is off the grid. So I'm going to change to green when I graph that point. On a test or a quiz or a homework assignment, if you ever have a point that's beyond the limitation of the graph, I'm not going to require you to graph that. Okay, that's why I put it in green. It's my way of communicating. You don't have to have that on the paper. Okay? And now I'm just going to connect the dots to create my graph. And I'm done. And here's the nice thing. If you have any doubts, like did I do this correctly or not, go back to your graphing calculator and hit the graph button. Not second graph, because remember, second graph is the table. But if you just hit graph, you see a copy of what you just created. All right, so like the X button. All right, so the question was, where does this X come from? It comes from the button right next to the alpha key. It's the button that has the X and the T and the theta and the N. All right, we got 3 more problems, and I'm going to, I'll do one more kind of at the same pace, but the last 2, I'm going to pick up the pace a little bit. Okay, and again, it's up to you to interrupt me if you have questions. Okay, here we go. 3 more problems, and then we're done for the day. Okay, this one's a little weird. Okay. Does anyone know what those vertical bars actually mean? Starts with the letter A. ABS. And actually, ABS is how you can find this command. All right, it's absolute value. Those vertical bars, basically all they really mean is ignore whether the number is positive or negative. That's literally what it means. So if you were going to show your work, which again, I'm going to show in green, okay? All this is saying is if you think of a number, take that number and subtract 5 from it. And then the vertical bars mean I don't care if the result is positive or negative. That's literally what it's saying. So for example, -5 minus 5 is -10, but the vertical bars mean I don't care that it's positive or negative. Just tell me the number. -1 minus 5 is -6, but the vertical bars say I don't care if it's positive or negative. Just tell me 6. 2 minus 5 is -3, but again, the vertical bars, I don't care if it's positive or negative. Just tell me 3. Next one's a little weird because 5 minus 5 is 0. 0 doesn't have a sign. It's not really positive or negative. So I'm just going to write 0. And the other 3, I would argue, are a little more straightforward because 7 minus 5 is 2. Well, the absolute value of 2 is 2. Okay, again, absolute value does not care if you are positive or negative. Visually, what absolute value represents is how far from 0 are you. So imagine, if you would, for the people listening to the recording, I'm going to ask people to imagine I'm standing at 0 on a number line. Okay? So imagine the numbers off to your right, my left, are positives, and the numbers off to my right, your left, are negatives. If somebody is standing over there on positive 10 and somebody else is standing over there at negative 10, they're both 10 steps away from me. Does that make sense? That's what absolute value is. It's how far from 0 are you. And so I don't care if you're positive or negative, you're the same distance from 0. Okay, and then finally, 9 minus 5 is 4, and you got it. 10 minus 5 is 5. Now remember, when we're graphing these points, the first number is how far left and right you go. The second number is how far up and down you go. And for every one of these points, you imagine starting at the origin. And if it's negative, you go left. If it's positive, you go right. And then if the second number is negative, you go down. If it's positive, you go up. So it's left or right, then up or down. Okay, so the first point is negative 5, positive 10. So I'm going to start at the origin, and I'm going to go to the left 5, and then I'm going to go all the way up to positive 10. For the next point, negative 1, 6. So I'm going to go left 1 and up 6. For the next one, I'm going to go to the right 2 and then up 3. For the next one, 5, 0. That one's kind of weird because it's saying go to the right 5 and then don't go up or down at all. Just stop. Okay, so 5, 0 means go to the right 5 and then do not go up or down at all. Just stop. Then we've got 7, 2. So over 7, up 2. Then we've got 9, 4. So over 9 and up 4. And finally, we've got 10, 5. So over 10 and up 5. And believe it or not, because absolute value says ignore the negatives, it basically acts as like a bounce off of the x-axis. So you get a kind of like a flying V. This is the type of graph that absolute value produces. All right, go ahead and turn the page. Okay, this one, I'll warn you, I'm going to go a little bit faster on this one because the equation is x squared. So all we need is x squared. So let me go to my calculator. I'm going to reset my calculator. Second plus 712. That gets rid of everything. Now I want to type into the equation x squared. Remember, your equations go into y equals. It's that button in the top left corner. So I hit that button. And now all I need to type is x squared. Remember, x is that funky button next to the alpha key. It has the x and the t and the theta and the n. And to make it squared, there's literally a button that says x squared. I'm going to hit that button, and it turns it into x squared. Now, I'm going to copy my table, okay, starting at -3. So when I go to my calculator, I want to look at the table, which is the second feature of the graph button. So I hit second graph. And remember, again, I want to start at -3. So I'm going to go up until I see -3. And now I'm just going to copy those values. 941, 0149. Oh, that's a lie. I have to retype that later. What's up? All right, so again, I like Mr. Fee's idea of showing the work for the first one, just so that it makes more sense of where that number came from. But for the rest, if you just want to write the number down, I have no problem with that. Now, for graphing these, we've got -3, +9. So I go left 3, up 9. -2, 4 is left 2, up 4. And remember, again, for every one of these points, I'm starting at the origin. I'm imagining standing in the center. And then I'm worrying about what direction I go in. The next point is -1, 1. The next point is kind of an interesting one. It's 0, 0. That literally means don't go left or right, don't go up or down. Just stay where you are, which literally is the origin. Like that's the point in the center. Sometimes you get that exact point. In fact, that's a really common point for a lot of graphs. Okay, then we have 1, 1, 2, 4, and 3, 9. And you end up with this curve. And by the way, if you're looking at these points and you're wondering, how am I supposed to connect those dots? Remember, you can always hit graph and look at the thing that you're trying to create. Okay, and you can see it's like this upward facing curve. All right. And I think what I'm going to do, just for the sake of time, because the bell's going to ring in about 3 minutes, I want to give you some time to pack up. We're going to call the class here. While you all are packing up, I'm going to go through the last problem we didn't quite get to today. That way, if anyone wants to watch it in the recording, they can get it. Okay? So feel free to get packed up. You can keep your binders with you as long as you remember to bring them to class tomorrow. Or if you don't want to worry about remembering, just put it in the back in the bookcase over there. Okay? And also remember to return your calculators. All right? If you're watching the recording, I'm going to go ahead and show my work for this last one. All right, and then if I graph these points, we end up with the following curve that slowly increases as it goes to the right. And that is it. All right, so thanks for watching. Based on today's lesson, students should be able to complete homework number 1. Have a good day.